hull coatings and anti-fouling. And basically, iTech have got a new product that they've brought onto the market. There's a bit of a revolution in terms of how it does its job. I'm going to introduce now Philip Shaban, CEO of iTech from Gothenburg, to introduce the company and the concept, and then I'm going to introduce the panelists from within the shipping community and the hull coatings community as well, to come and have a discussion with me about just how revolutionary this is and what we mean by hull coatings and disruption in this context. So please, Philip, if you may. And I'll stand aside.
All right. Does it work? Is it on? Can you hear me? Yep. Hi, everyone. We're very proud to be here today, not only because we're making quite a lot of progress to afford a trip from Gothenburg all the way up to Oslo, but also for the fact that we are finding for the first time in quite a long time a context in which crazy people like ourselves actually could feel at home in this disruptive entrepreneurial corner of North Shipping. It's a great pleasure, obviously, to have this opportunity to discuss the ways of improving this area, an area that we have struggled with, not my personally, of course, but thousands and thousands of years since sailing and seaborne trade ever started. We've been fighting this issue of fouling. And all kinds of solutions have been tested, sometimes in terms of desperation, sometimes actually quite good attempts. But the only thing we've been learning, because we're actually standing here 2,000 years later, is that everything is changing to the extent that nothing that was good yesterday will be working satisfactory tomorrow. We have to adapt to change all the time. And that's where iTech comes in. We only exist because we think that small incremental changes will not do enough. The global shipping community has a super impact on everything we do. Globalization is completely relying on shipping, so we have to make sure that chain is as efficient as ever possible. And we know that the industry is suffering changes all over the place. We have seen seawater temperatures increase, which puts pressure on the underwater coating systems. We're seeing different trade patterns, being more idling in terms of the use of the ships, trading into different waters, maybe warmer than before. We're seeing regulation. Maybe the most disruptive part of anti-fouling is the regulatory part of it. There's been so many changes, and you don't have to go back that far in time, which put everything on a different plane, so to say, right? You had super duper functioning things, and a few years later it didn't work for other reasons. And parts of this actually spells advancements of science. We are now aware of so much more than we were before. Solutions that maybe worked yesterday are now shown to have adverse effects sometimes. iTech has been developing through science. The picture behind you is something we're very proud of. The research started when the regulation really tipped things over back in the 1990s. The idea was then to come up with something that could reduce friction and then respond to the needs of reducing the fuel and emissions to air and sea. But it also had to respond to the regulatory landscape that was in front of us. And we know that only 10, 15 years ago, there was 0 endpoints to be assessed against. Almost everything passed. Of course, it had to do a good job in terms of efficacy and so on, right? And now, 10, 15 years later, we're finding ourselves in a situation where we have to respond not only to your ship owner demands of reducing fuel and the paint maker demands of having compatible and cheap products or cost-efficient products, but also to a regulatory world with more than or around 100 different endpoints to comply with. How do you do this? We took it from a scientific standpoint again, starting off with a cross-functional research team back in the University of Gothenburg that looked to the biology of the problem, the biological aspects to it, looked to the chemistry of it, looked to the physics of it, and also obviously to the industrial side of it, including the business side. What came out of that was quite surprising, and this is where a disruption was made. The researchers found, crazy enough, the mechanism of why some of the most undesired and unwelcomed creatures actually attach on a hull. The barnacles attach so hard that they normally have to be hard polished off, so to say. They have to be taken out by mechanical measures. By knowing how these creatures work and how they function, you could screen pharmacological compounds. You could screen theories that couldn't be done before to come up with a solution. The fundamental idea was, of course, come up with something that was efficacious, a lot more efficacious than something we have seen before, but still within the framework of the regulation. The idea was also to have a small amount of biocides as possible in a paint. And this compound, Selektope, responded to that. It responds to that because it's actually relying on its mode of action. And you may care less or care a lot about the destiny of a barnacle. We love barnacles, and we can probably show you barnacles in every shape and form if you want to. But the important thing is, by having this selective mode of action, we can, with very small quantities, create a change. And that's what you're seeing on this picture behind me. Only nanomolar concentrations, a few grams per liter paint, was used in that anti-fouling coating to create that static performance. And that opens up a new dimension for the paint makers and hence the ship owners. Static performance can now be treated completely different than before, or at least a new tool has been available to improve the static performance. One of the greatest challenges for the ship community today. And we're doing this because we're creating a flight mode to the barnacles. We're triggering a behavior for them to swim away. And this is where disruption comes in. So on a small scale, this is disruption. Throughout the 2000-something years, we've been working anti-fouling. It's all been focusing around lethal mode of action, toxic mode of actions. And now, for the first time ever, we are having paint makers applying a biorepellent containing anti-fouling on ship hulls. It repels the barnacles, and that opens up for other dimensions. So how does this help us move forward in this industry? Well, first of all, we're acknowledging that only through science we can meet these new demands that the surrounding environment is putting on us. We can't go on a trial and error basis anymore. We cannot even just stay still and not do anything. Things are changing. And that's why we're thinking that this is going to help the community reach its new targets of being more efficient and responding to all these changes. iTech is a relatively small company, showing also that a great deal of change can be done with small measures, only if you have the right attitude. So even if you have the greatest scientific discoveries alongside, you won't succeed. You also need a great deal of passion, and you need some crazy people who know how to make their haircut in the morning, and you need crazy people who are, despite 1,000 years of research and use of anti-foulings, still think there's room for improvements. And we're welcoming this nice set of panelists, the prominent panelists, to discuss this topic further. Can we use scientific measures to further disrupt things? Or how can we make this take the next step into further improvements? So by those words, Craig, I'm happy to introduce the panelists.
Question for you first, though. Yep. When you came up with this idea, and when you found this, and it's sort of eureka moment, yep, were you looking for something specifically that did the repellent, or were you looking for something that specifically dealt with the barnacle problem?
The key thing was to deal with the public enemy number one, which was the barnacle, right? Because please remember that there's 2,000 species involved in this problem. It's not an easy task. That's probably the reason why we're still discussing this after so many years, right? And it happens then that the way to keep concentrations low and give flexibility is by using pharmacological concepts. So that's
how did you find that? How did you find that pharmaceutical solution? At what point did you say, I'm going to choose this? I know what it is. Maybe the audience doesn't. But how did you sort of like come across that one? It's, to me, when I look at what it is that you're using in this electrode, it's not an obvious choice for me to go, oh, that equals a repellent.
Right. And it's not an obvious choice even if you know the science behind it, because as you know, it has other effects in other creatures, right? You know, it's being sedative in its mode of action in other creatures. Many great discoveries is a bit of a good luck and chance that negative control actually resulted in a completely different mode of action. In this case, a repellent mode of action. So it stimulates barnacles to move away from a surface containing this product. So it was a little bit of luck, and obviously some sort of well-known matrix of compounds that could address this physiology that we knew about.
Do you want to introduce the panel as well?
Yeah, please.
Could I ask the panelists to come up now? Maritime, Per Wingby, Naval Architect and Project Manager at Stena, Ralph Catan, who's Managing Director at Safina, and Tor Svensson, on the board of Safina and also the former Maritime CEO at DNV GL. Thank you, gentlemen. Be careful with those microphones, please. They are quite sensitive. But don't worry, they don't bite. You don't have to stand so far away from them. I'm going to go, if I can, to Ralph here, because with the Safina, you've been looking at hull coatings and the hull issues for a number of years now. That's your specialised topic. How have you seen the evolution of hull coatings over the years? And when we're talking about the element of disruption that we were talking about, that Philip was talking about, how disruptive from you is this as a product? Brand new.
Thank you, Craig. You're right. Initially, the biggest disruptor was really regulatory.
You get closer to the microphone, please.
The initial disruptor was initially regulatory. That's what really changed the ball game for everybody. For many years, we settled on PET as being another solution. It provided a predictable performance, and everybody was happy. When the regulations came, everything had to change. There was no choice. What I believe was that the solution envelope would start to broaden. Would look for alternative technologies, alternative solutions to create the next generation of fouling prevention technologies. And that's what has happened. I have to say that what I had thought was by about now, the solution envelope would narrow again. We would never settle on one technology. There would be a range of technologies that would meet the needs. However, even today, I'm seeing more and more innovations coming in fouling prevention across the range, and so the envelope is still broadening. One of the challenges and I'm not a chemist, I'm a naval architect. I've served my time painting ships in many ways. But what I understand, one of the challenges of a new ingredient coming in is what impact does it have on the formulation envelope that the chemist can play with. And there have been products in the past that have showed a lot of promise, but narrowed the solution envelope in terms of formulation. What I understand from the chemists in Safina is that ITEC allows a broadening of that envelope and the possible solutions. So whilst ITEC, or the Selectcoat product itself, is not the only ingredient we need, it needs other factors to help it perform as a total anti-fouling. It does allow the formulator to have a broader solution envelope, and that becomes an interesting option.
And I guess here, this is the thing, Philip, is that it's not a coating in itself, I believe. It's an additive that goes into a coating.
When we talk disruption, this is a disruption on a lower level, right? The whole idea was here to not deviate from the coating manufacturer's original platforms, because then we would have need another 50 years probably to get out there. The idea was to create something that's compatible, almost like a plug-in to the paint maker's broad range of systems, right? So the disruption level is on the lower tier, and thanks to the compatibility, we're standing here and seeing progress commercially being made.
So you're basically your immediate client is the hull coatings manufacturers, really, rather than the ship operators and owners. Yeah. From the ship operating owning perspective here, it's, you know, I've been to a lot of presentations and I've seen some of the suggestions about this hull coating, that hull coating. Can I ask you, Michael, first? How cautious were you when you heard that there's a new product on the market or being developed?
Rather cautious, actually, because we have tried quite a few different solutions through the years and through different anti-foulings, and some of them have been pretty good, some of them have been less good. So you always want to go with something that is proven. But on the other hand, unless there's a little bit of trial, there's no progress. So we thought, we started with test patches on the ships, and they proved that the product was working the way it should. And now, a year and a half back, we did a full ship, which so far has a fantastic performance. So far, a little bit of risking it and trying has worked out really well for us. But you do want to start small. Everybody wants to have full security in what they do. But the benefits, when you get it right, are really there.
When you're doing these sort of trials on behalf of a hull coating maker or a selector, have you had to go through extra hoops when it comes to regulations and port authorities and say, look, we've got this product on the hull, it's a little bit different?
Yes. Regulation, as Philip said, is definitely a problem. You have to have a paint that can be, or is allowed to be used in the country, that is allowed to be used by the workers, that is allowed to be used on the hull. For test patches, we found that it's reasonably easy to get over that. And now for the full ship, it was workable as well. But it wasn't just to bring the can of paint to start painting.
Okay, what about your experiences then?
We have not gone so far as Michael just explained. We have had a couple of test patches, and actually as we speak, we have a Suez tanker being docked this weekend, and we will see the result from that. But so I cannot really say about the result yet.
So still early days for you, but you're optimistic based on what Michael's been able to demonstrate so far. As I've always said, you know, if Coca-Cola told me to drink Coke, I'd say no, but if my mate told me to drink Coke, I'd probably have a glass of Coke. So the fact that you've got the evidence from a neighbour ship owner has probably sort of helped ease that caution, I imagine. Tom, how do you see this as a sort of environmental solution?
I think when we talk about disruptors, we tend to talk about now how to beat the anti-fouling, but I think there's another disruptor in this if we look at the regulatory angle also. And that's disruptor is that you're going to, in the future maybe, in a few years' time, be denied access to a port if you have fouling on the ship. You know, we are seeing exactly the same developing as we see in the ballast water, and what's the difference? Something swimming around in the ballast water versus something that's attached to the hull that might actually spread in the local environment. And this is actually driving us in a direction where we need to solve this, and we need to find new solutions. I think there are, in a way, there are two ways. Either you deal with how and make sure it doesn't attach to the ship, or you deal with actually cleaning and keeping it off by mechanical means. That's at least what we see as the opportunities at the moment. And actually somebody suggested to me a few weeks ago, why on some expensive ships, why don't we just build them in stainless steel and we scrub them all the time? I don't think that's a good solution. I like much more the idea of playing with the chemicals or the biochemistry and finding a way to actually prevent these things sticking. That was the original idea of silicone paints. I know it didn't really work out, and maybe to the extent we wanted it to. But I think be aware of the regulatory, be aware that we need to find some disruptive solutions here within a time window of maybe the next 5 or 10 years and make it work. Otherwise we're going to have a bigger job at our hand. And secondly, just one more point on it, and that is it costs us an awful lot of money to have fouling on ships. You know, you just do the sums a little bit in the head and say that if the shipping industry uses 250 million tons a year fuel, and on average, I don't think I'm exaggerating if I'm saying that on average ships lose about 10% in performance if you look roughness and fouling in combination, and then do the sums on that, and even if you cut that in half, you have $5 billion to play with. That's in a way the benefit, and also the environmental effect on this, that you are emitting less to the air. So. But there are many good arguments.
There was a vessel recently, earlier this year, that wasn't allowed into New Zealand because of the condition of its hull. It got forced to go elsewhere, and I think initially its next port of call said, no, we don't want you either. So there really is this sort of pariah of having your hull extra dirty, covered in whatever. But that also begs another question I've got. You're talking about barnacles. There's more to hull life than barnacles here.
That's why we're not coming up with a full new solution, right? We're bringing another tool to the toolbox, which obviously paint makers are using and looking at to respond to those things that you're talking about. We discussed earlier, right? What's the driving things for the hull coatings? Invasive aquatic species is now coming up as one of the big things to avoid fouling. Hull coatings need to be more powerful, or more reliable, more consistently performing at least than what they've been in the past, because the regulation on that side is going to increase. On top of that, you have those fuel efficiency aspects, you have the emissions to air, and you may have even emissions to sea at one point to consider. So you need to come up with solutions addressing that, and this is a part of it. For the rest of it, we have other prominent fireside suppliers, of course, and chemical binder systems and whatever else the paint maker community is using to control the soft fouling part of it.
How do you see the whole industry developing, Ralph, here as we go through? As I say, you've been watching this evolve, and you mentioned that you see the regulation as one of the key aspects here. Are we going to see stronger regulation coming in, and with that, are we going to need stronger solutions?
I think the key issue, what does the end user want out of their fouling prevention solution can be summed up in one word. They want predictability. They want to understand that if they apply any system, whatever it might be, the performance of the vessel over the life of the system is as expected. Therefore, whether it's fuel saving, fouling prevention, behaviour of the vessel to meet charter party needs, enter port, and so on, is all predictable. So any developments that result in, say, formulation changes, etc., will always create a degree of instability before you reach predictability. So the industry often compares these new generation products back to TBT products, but we forget that the TBT products evolved over 20, 30 years to get stability, and these new generations of products are still in their early days. So what the industry wants is a predictable performance over a long period of time, and that's always going to be the challenge for the innovators, the developers of new technologies, and the formulators in how do we deliver that. What we are seeing as a company today is that there is a much broader, as expected, a much broader level of variability in the performance of fouling prevention systems than we had 10, 15 years ago, or 20 years ago before the ban. And that is what owners are now really looking for. When we talk to them and look at how the different products that they've applied are performing, that's exactly what we're seeing, a lack of predictability in performance. And that becomes, for me, the key challenge for the industry over the next 5 to 10 years. The difficulty in trying to meet that challenge is I don't ever see the regulations stepping backwards, so I don't think the regulations will get any looser. The only thing that will happen is they will get tighter, and therefore I think you're always going to be operating in a much narrower envelope, and so the predictability of performance and the longevity of the products become critical. as has been alluded, it's not a matter of 1 month or 6 months to develop a new product. You're talking years. And if it takes, let's say today somebody has a novel idea and it's going to take 10 years to get it to market, the regulatory environment in which they're going to emerge could be very different and could actually have stopped that development well before it even gets to market. So the big challenge today is simply getting the product out there working and then be able to evaluate it over a reasonable period of time over a range of product types or vessel types to make sure you get that predictability.
And Tor, what about talking about the regulation from the class perspective as well? From dry docking to dry docking, I've often perceived that the hull coating is seen as it must have that robustness, that 5-year period in between dockings perhaps, and then there was the potential of having extended dockings as that. Has that put added pressure on the performance of hull coatings?
I think there's a clear wish amongst owners to extend the dry docking interval. For certain ships, there's been pressure to extend up to 7.5 years, where the regulation can allow that. And I don't think, honestly, that we have the paint solution that really works for that today. And therefore, most have actually been forced back to sort of the 5-year cycle. Some actually dock more frequently, and as a matter of habit, docks every 2.5 to 3 years also, in order to keep the performance in top shape. So I think that's the reality today, and there is certainly a potential for certain ship types to extend from a regulatory point of view. There's another element also which I think is important to add. We build ships today generally with about 20% service margin. So we install a service margin. You need some for wave, weather, wind, weather conditions that because of the added resistance. But do you need 20% for that? No, because you are anticipating to lose quite a lot of performance with fouling and hull roughness. If you can reduce that, you can actually reduce installed power. And you're actually also reducing the ship price, and you're actually meeting easier the energy efficiency index and things like that. So there's a knock-on effect, which is important. It's not just a daily fuel, it's a further knock-on effect.
But to do that, you'd have to have the robust assurance that the hull coatings would perform for that length of
Absolutely.
period.
You don't want to end up in a situation when you're underpowered and don't have enough margin and get into all kind of problems, even with your propeller and being on the wrong point of the propeller curve and things like that.
What's your experience in Stena of hull coatings? Generally, I mean, without naming names, clearly, but there must be some hull coatings you go, oh, I'm not going to touch that again.
Okay, that was a very broad question, but it is a science, and we are struggling, I can tell you. We have tried a lot of different coatings with different results, of course, but we put a lot of focus on it, because for us it's performance, or first of all that the anti-fouling should survive during a docking period. At least 2 or maybe 3 or even 5 years with no fouling. And then we come to the fuel consumption. That is very important that we have a very smooth surface. So we look on all those 2 factors to sort of judge the product.
When it comes to the actual mixing of the Selektope into a hull coatings product, I guess it's not just a question of taking a pipette and putting a few drops into a can. You've got to assess what the impact of the Selektope is, as well as the other properties of each individual hull coating.
Yes, and I kind of wish it was so easy that we just could drop in a few drops in every paint can when they're basically sitting on the shelf, but that's not the reality, right? We're actually spending with all these paint makers, I don't know, what is it, about 10, 15 years of dialogue, cooperation, and whatever else to try to figure out what's the best measures of
Because different hull coatings have got different properties, different speed. We were talking earlier about, different vessels or different hull coatings have been designed for different kind of operating conditions, kinds of ships.
There are so many barriers here to create any change whatsoever, right? That we have to acknowledge that when we work on disruptive technology. It's not only coming up with this good research idea and then hope that 3 weeks later we would sell to Stena or to Jotun or to Shiruko or whoever else would be using it, right? No, that's not happening, right? It's years and years of